did like a video on stack data structure using arrays. This time around I am like actually creating queue using like I am implementing queue data structure using arrays in C language. So there you go. This is the program. Here there is int ARR of 5, and like the space there are 5 elements in this, and you can see 1 2 3 4 5 are the 5 elements. Now the rear is 4, like you can see 0 1 2 3 4, right? So like the index is up to 4, so rear is 4, front is 0 because the first index is 0. Now there are 4 functionalities. First we can check if the queue is empty or not. Second is it will display us all the like elements of the queue, or what we want to call them, right? So I'm calling them elements, like you can call them whatever, right? And then there is enqueue, which helps us like insert elements from the back, I think, and then dequeue will allow us to remove elements from the front. That is how queue works, right? It's like last in first out, isn't that right? I mean, no, I think it's last out. Whatever element enters last, and that element is the one that goes the last. So let's see, if we insert something over here, then the last element to be executed, or the last element to be searched or whatever, is going to be the last element, right? It'll be last. The first one is executed first. All right. So now we are going a little bit further into the program. Now there is I've written these things randomly. First we display them in dequeue, then we display them in dequeue, then we display them in dequeue. This continues, and then finally we enqueue. So let's see. Here's the result. So that is 1 2 3 4. You can see in the bottom, right? 1 2 3 4 5. There are 5 elements, and one was dequeued. Then there is left 2 3 4 5. Then 2 was dequeued. All right. After that there is left 3 4 5, and then 3 was dequeued. Then only 4 5 is left, then 4 was dequeued, and then only 5 is left, then 5 was dequeued. Now nothing is left, then we enqueue. What do we want to enqueue? So I enqueued 6, and only 6 is left inside this. So we are going to change this. This is very inefficient or not right way to do things. We're going to change this. Alright, so what will int yes is equal to 0 or 1. Alright, then we'll create a big do loop. Inside it we will give options. So what are the options? First one is enqueue. Let's make it caps. Slash n cannot be capital. 2 is dequeue. QUE, right? Third one is display. Now the fourth one is, wait a second, there is another video. And the fourth one is empty. Is empty will be like this. Alright, and double slash in here. Now that we have given them options, at this point we want to take input. So int cell, now it has initially nothing, print it. What operation do you want to perform? These will be wrapped inside of these, right? And then scanf %d. Now here we have to have ampersand sign, and then we will take the input in cell, right? Now we will use a switch statement. Switch statement in cell will be the input, case 1 enqueue, right? And then that function will be executed, then we'll break the case, and then do dequeue, right? Wait a second. Dequeue, and then break case 3, enqueue, dequeue, and then go to display, right? And break, and then case 4. Now enqueue, dequeue, display is empty. And break. Now one more thing, default. What should be the default? Printf invalid selection. Invalid selection. Please choose correct operation, rather option slash n. Alright, so at this point we are pretty okay. Now we are inside a do loop, right? So it's do while loop, so now we need condition, right? So there was yes, right? Initially there was a variable named yes. Here you go, and I have written it like given it a value of 1, rather stored 1 into it. Now here we need to use that value. How? If user wants to continue doing operations, then they'll have to enter here. Do you want to continue performing these operations. One is for yes, one for yes, anything else is for no. Now scan it to collect it, percentage d and ampersand and yes, so they will put the value. Now while yes is equal to 1, if it is equal to 1 then the loop will continue to execute. If it's not equal to 1 then the loop will break. Alright, now we compile the program gcc, and then there is this what should I call it, dash, and then small o, and then q is the name of the program that I gave, and main.c is the actual name of the program. So executable's name comes first and then the name of the main program, that is main.c, right? There's an error in line 22 25 point so 25, there you go, that is the error. It's good that we can find out what the error. Perfect, no error this time around. Let's check if things are working properly. So right away we are getting our options, right? Enqueue, dequeue, display, empty. First we will go to display. So they displayed us 1 2 3 4 5 is there. 1 for yes, so yes I do want to. Now let's dequeue. So 2, 1 has been dequeued, 1 for yes, 2, 2 has been dequeued, 1 for yes, 3. What question do we want to do? Actually 2, right? We want to keep dequeuing. 3 has been dequeued, 4 has been dequeued, 5 has been dequeued. Let's do one more time. Q is empty, right? So now Q has nothing in it. Q has absolutely nothing in it. Now let's see. I should actually make, I mean to easier, I should have given it an option of displaying rear and front, so that we could fix all the errors if there are any. So now we would like to enqueue. Yes. So what we want to 450. Next 455. Oh, sorry. I just. What option do we want to? Oh, I just mistook that. Anyways, let's continue with one options. Which option do we want to enqueue? What do we want to enqueue? Let's say 1000. Alright. So wait a second. This is not how queue works, right? This isn't how queue works. There you go. 1000 was added on top of 450. That's not how it works. Let's see. There is some sort of error in queuing. Let's see. When we enqueue, if front is greater than 0, we do that, right? But why do we decrease the value of front? We shouldn't decrease it. Or rather, the value of rear should increase. Because rear is decreased every time queue is empty, right? Wait a second, we'll have to figure this out. Sorry. Let's just say we want to check 4. It is not empty. 0 for stopping it. Anyways, let's look at dequeue here. Because we are removing from the front and we are enqueuing from behind. So let's see. If front is less than equal to 4, so from there we dequeue, right? What we need to do is we are adding from rear, right? It's not from front, it's rear. So it's if rear is less than 4. If it's less than 4, then we can enqueue, right? And we increase the value of rear, right? Rear plus plus. Alright, now it's a little bit better. CLS, and then CLS is for clearing screen. Now here we want to actually compile, and now we want to check if the program is working properly. So for that we need to do something. And what do we do? First we will dequeue all the elements, and then or rather dequeue one and try to enqueue one. Alright, so let's so it might not work properly, but it's okay, right? We are just checking if it's working. Let's try to dequeue, or rather enqueue one. Not enough memory because the queue is full, right? The rear is equal to 4 actually, so that is not happening. We'll have to fix. We have to sometimes do shifting in this. We'll see, right? If we keep dequeuing from the front, then the space in the front will be left and the rear will be still the same. That's why we need to shift elements at one point. But for now, this is enough. We'll dequeue, right? What? That's not. There you go. Now here we need to dequeue. One has been dequeued. Yes, I want to continue. Now can I enqueue? No, because the rear is not changing. The rear is not changing. So until and unless we have absolutely cleared the queue, we will not be able to put any element in there or enqueue. So let's see dequeuing. All elements have been dequeued. Now display 4 right. It is so there's some sort of error in is empty as well because there's nothing in the queue. What would I like to do? I like to do display. There's nothing in there, right? Okay, so let's try to enqueue, right? Enqueue. Not enough memory. It's still so rear is not changing when we are dequeuing, and that's what's happening. So let's say front, different, uh, we should be able to. If it was circular, then that would have been better, and that is like one of the things people normally like do circular to implement circular queues for this very reason. We'll solve this problem, right? Next video will be on circular queue, that I will fix this problem of like the wheel not moving, and like everything is in the way everything should be the way it should be. I think this problem was not there in linked list. I can already fixed it, but in array I will have to think about it, and then next time around when I make this video, I'll make it clear and I will create a circular linked list. Thanks for watching.